know that those things that you can buy in a dollar store, or maybe you can order them online, are really, really cool for science demonstrations. If you get them home, you might ask another question. What will happen if we put them, instead of in water, as we did before, and as we're doing now to see how they grow, what if we put them in oil? For example, canola oil that we're using here. And you will discover that in oil they will not grow. Then it begs a question, why? And the reason for it is that the molecules of oil are very big, heavy molecules compared to the tiny and very polarized molecules of water. And if you looked at our electrostatic demonstrations, you will know that polarized molecules means that of water, that the H2O, 2 hydrogen atoms and 1 oxygen atom, they have both sides of the molecule have very different signs. The H atoms have more, the positive side is the hydrogen, the negative side is the oxygen, and even though in total it's neutral, the sides are polarized. So those polarized molecules are attracted to very long braided molecules of this material that the bubbles are made of, and this way how it grows. So you can ask lots and lots of very cool questions about it. So for example, if we start looking, and we're going to shine some light on them, if you look how they grow, and we're just in the midst of the growth, you can see that while the final state, you can see that the final, they look as spheres. I'll put even another one here. But at the beginning, when they start growing, they look almost like tiny diamonds. They have very, very interesting shape. So the interesting thing about it, you can ask lots and lots of questions. Why? How does it happen? You can also ask, how much bigger is the fully grown sphere or bubble than the original one? And the interesting thing about it, that the volume of the bubble grows as the cube of its diameter. So if the original one has a diameter of about 3 millimeters, and the final one has a diameter of, let's say 2 centimeters, which is 20 millimeters, about 7 times larger, the volume is going to be, the ratio of volumes is going to be 7 to the cube to the power of 3, which is more than 200. So the volume of the fully grown bubble is 200 times more than the volume of the tiny bubble, which is really, really cool. So with very cheap equipment, you can ask a lot of very interesting mathematics and science questions. And we'll keep waiting and seeing what happens along the way.